Okay, people at home, I'm going to post these notes on Google Classroom, and you can take some notes in your notebook off of the PowerPoint that I post. But I would suggest that you watch the video like you were in class. Now remember, I can't live stream to you because we don't have the bandwidth, but I can upload videos like this. There's going to be a lot of important information that I'm going to go over right now. So I suggest you just watch the video. Like I said, if you're playing it back on YouTube, you can play it back at 1.5 speed or 1.25 speed, and maybe you won't be as bored. But also, if you want to just take these notes, I'll post them on the Google Classroom. But there will be questions and assignments, and these notes are related to the lab that we did. So choose how you want. I'm going to zoom in on here, and hopefully that looks good. All right. All right. States of matter. What are the three big states of matter? Now, normally, from fourth grade, you'd be like, well, it's solid, liquid, and gas. Well, there's a lot of in-betweens here too, like Jell-O, right? And cornstarch and water, right? You guys know what I mean? But really, solid, liquid, and gas on Earth, these are the ones you deal with. But in reality, most of the matter of the universe is stars, right? It's caught up in stars, like our sun, and that's plasma. So really, solid, liquid, gas aren't the three big states of matter. Plasma is the most popular state of matter in the universe. If I was wrong about that, I'd be super surprised. Now, let's talk about what it means to be a solid, a liquid, or a gas, all right? Now, I'm going to a webpage here called the PHET, okay? P-H-E-T, University of Colorado. They've got all kinds of cool stuff. And here we go. All right, now look, this is what a solid is like. All right, you don't need to write anything down right this second because we'll get some words for solid later. But these little blue circles, these are the molecules. And we're going to say this is water, okay? It says it's neon gas right here. I can change it to water. There we go. And let's go with neon gas because it looks neater. Okay, so this is a cube of neon gas. Yes, neon could be a solid if we made it cold enough, right? All right, so this is a cube. It's a solid. Now notice that the little molecules, they're shaking, all right? They're shaking and they're rotating. That's what they're doing, all right? But they're not switching places with each other. That's what it means to be a solid, okay? Now, if we're looking at a liquid first, the things in the liquid are in the bottom of the container from gravity, right? When you pour yourself a drink, it's in the bottom of the container, right? And if you look, the liquid molecules, they're trading places with each other. And another thing you'll notice is that they pull on each other. They have a force that pulls, there's an attractive force, okay? An intermolecular force. They're pulling on each other, all right? So that's what a liquid is like. Okay, and you're like, well, what are these? That's some of them at the surface have broken the force where they were hanging on to each other, and now they're going away. What do you think what state of matter would that one be? You might have a guess? The gas, that's right. So gases look like this. Gases have no attraction for each other, and the molecules interact with each other. They just bounce off. Theoretically, they don't even slow down, okay? And they bounce off each other in the walls of the container. All right? So that's what solid, liquids, and gas means. Now let's go back here to solid. All right, this is going to sound dumb, but how do we change a solid to a liquid? Tell me, what? Is somebody saying something? I ask all of you high school honors chemistry kids how to change a solid to a liquid. Heat, that's right. Warm it up. I started saying, and my third grade daughter at home would be like, heat it up. And y'all are like staring at me like there's some trick answer. There's no trick answer, right? I'm not trying to trick anybody, like smiling. under here. That's a joke. I'm smiling though. That's right. Okay, looking at me with those dead eyes. Anyway, you just warm it up. So what we do, warming it up is giving it energy, right? So we give it energy. Isn't that what we did yesterday to the ice we had in the beaker? We warmed it up, we gave it energy. Okay, so if we give it energy, whoop, warming it up there, can you see that working? Putting a little flame. Now if we give it energy, these molecules have enough energy to break apart from each other and start switching places. Okay? So down here, these are the liquids, and I gave it so much heat. Some of the molecules went to gas, they evaporated. Okay? But these guys right here are still pulling on each other and they're switching places with each other. So that's what we did. It took energy to change it from solid to liquid. Now this is important. I know you're like, I know all this stuff. But we're going back to yesterday's lab. Okay? So just remember the statement. It takes energy to change something from solid to a liquid. Now how am I going to change this all to a gas? What am I going to do? More energy. That's right. More heat, more energy. So I'm just going to lay it to it. Flame on, people. And these molecules are getting more and more excited. More heat energy is being changed into the kinetic energy of the molecules. And they're moving faster and faster. And they have so much energy that they're no longer stuck together. They've broken apart and they're just flying around like a bunch of crazy people. All right, it's like recess. It's like first grade recess, okay? So these guys are done. They're moving around. They're bouncing off each other in the walls of their container. So it took energy to change it from a solid to liquid. It took more energy to change it from a liquid to a gas. Now instead of gas, what could I do to make it back into a liquid? Now, that's what most people say, is that make it colder. Really, when we make it colder, we're taking energy away from it. Does that make sense? So if I put some ice here, then some of this energy will be transferred to the ice. That's why the ice melts, right? Does that make sense? So I'm going to put some ice in there. And some of that heat energy would be making this ice melt. And the energy that's making the ice melt is being taken away from the molecules. So now they're slowing down. They're slowing down. And the more they slow down, now those guys at the bottom, they're turning into a liquid, right? The energy is being sucked out of this environment. And these guys are now a liquid again. And if I want to take even more energy away from them, they're going to be stuck in place again. And now we're back at a solid, or what something you think of as like a cube of ice. Does that make sense? So that's how this works. That's how solid, liquid, and gas works. So now that takes us to another thought about energy. Okay? So I'm going to end this video right here on solid, liquid, gas. Done.